Hi everyone, and welcome back to another episode of Science. In this episode, I want to teach you how to calculate gravitational potential energy and kinetic energy as well. But before we do that, let's talk about the units that we're going to be using in our calculations. So we're going to be using joules, which is represented by a capital J. Now this diagram here summarizes what a joule actually means and what you can do with 1 joule quite nicely. So if you're taking notes from this PowerPoint, this diagram is quite nice to use. So 1 Newton is the force needed to accelerate 1 kilogram at 1 meters per second squared. So what does that mean? Basically what this is telling you that every second that goes by, the cube will get faster by 1 meters per second. I'm going to touch on that a little bit later as well. Now, what does 1 joule mean? 1 joule is the amount of energy required to apply a force of 1 Newton for 1 meter. So if you applied 1 Newton of force to a 1 kilogram mass and you want to push it 1 meter in distance, then you need 1 joule of energy to accomplish that. And using the metric system makes our numbers and calculations quite nice. Okay, let's move forward from here. You might also have to convert joules into kilojoules or even megajoules. So into your notes, you want to copy down this simple conversion. So 1 kilojoule, or kJ, is equal to 1,000 joules. So if you had 100,000 joules, you would divide that by 1,000, which would give you 100 kilojoules. 1 megajoule, or MJ, is equal to 1 million joules. You might run into calories as well, particularly if you've got maybe an American packaging piece of food. The Australian packaging always uses kilojoules, but you might run into calories as well. And 1 calorie is equal to 4.184 joules. Next time you're eating like a packet of chips or something, take notice of the energy density of that food in particular. First, have a look at the serving size, okay, which in this case is 27 grams. Now that's only about 11 chips. I mean, who opens a packet of chips and just eats 11 chips? And just 11 chips is 584 kilojoules. 100 grams of these chips is about 2,160 kilojoules. I mean, this packet was 150 grams. Can you imagine eating the whole packet? I mean, an adult daily diet only allows for about 8,700 kilojoules. So just 1 packet of chips is a massive hit to your daily allowance. So yeah, next time you're eating a packaged food, take notice of the serving size and the energy that comes with that serving size. Okay, let's take a step forward and have a look at the formulas that we're going to be using in this episode. So the amount of gravitational kinetic energy can be calculated, and the 2 formulas that we're going to use in this episode is GPE, or gravitational potential energy, is equal to mass times by gravity times by height. And I'm going to show you what those units are in just a moment. We're also going to be doing kinetic energy is equal to half times by the mass times by velocity squared. In the case of a roller coaster, there's a relationship between gravitational potential energy and kinetic energy. At the top of the roller coaster, you've got the maximum amount of GPE, gravitational potential energy, and as the roller coaster falls, it transforms that GPE into kinetic energy as it gets faster and faster. Some of it is also transformed into waste energy in the form of heat and sound, so the roller coaster will never be able to rise to its original height, and that's because some of its GPE is being wasted on heat and sound. If you want to go back to its original height, it will need to be hooked up to a chain to pull it up. But as the GPE goes down, as it gets transformed into kinetic energy, the roller coaster gets faster, and then it climbs back up the next hill. It transforms its kinetic energy back into GPE, and the cycle continues. Let's have a look at our GPE formula more closely. So if you're taking your notes, definitely pause here and note down the units that we're using. So GPE is equal to mass times by gravity times by height. Mass, we're always going to be using kilograms. So the question might try to trick you if it's using grams or tons or something like that. You always want to convert it back to kilograms. Gravity is valued at 9.8 meters per second squared. What does that mean? So if you were to jump out of an aeroplane, your speed will get faster by 9.8 meters every single second. Every second that goes by, you get faster by going 9.8 meters every single second. And so we say that 9.8 meters per second squared is your acceleration. Every second that passes, you get faster by traveling 9.8 meters every second. I hope that makes sense. If not, you might just want to look at another YouTube video explaining what acceleration is. The final unit that we're using is height, which is in meters. So again, the question might give it to you in centimeters or kilometers. You want to convert it back to meters. Okay, let's practice together. Sarah is 6 years old and has a mass of 30 kilograms. Calculate Sarah's gravitational potential energy. So we want to input these values into the formula. GPE equals mass. Now Sarah's mass is 30 kilograms. Okay, and I probably don't even need to write the unit. I can just say 30. Multiplied by gravity. Now gravity was 9.8 multiplied by its height. So A, when she climbs up a vertical ladder to the top of the slide. So her height is going to be 2 meters. All right, so the mass is 30 kilograms. I've put that into the formula. The gravity is 9.8 from your previous slide. And the height is she's climbed to the top of the ladder at 2 meters. So now maybe just pause here and grab your calculator and punch in the values here. So if I go 30 times by 9.8 times by 2, that gives me 588 joules. Pause the video here as well and have a go at question B. Okay, assuming you've paused the video and you've had a go, let's do it together. So her mass is still 30. Oh, it's a dodgy 30. Multiplied by gravity, which is still 9.8. Oh, it's tricky with the mouse. Multiplied by her height. Now she's at the bottom of the slide, so her height now is actually 0. And when you multiply by 0, your answer is 0. So her GPE is 0 joules. Okay, let's have a closer look at kinetic energy now. So any object that's moving possesses kinetic energy, and we can calculate that kinetic energy as well. Our formula is KE, or kinetic energy, is equal to half times by the mass times by velocity squared. So our mass is once again in kilograms, and our velocity is meters per second. Meters per second. So let's do a couple of practice questions together. A car has a mass of 1,300 kilograms. Calculate its kinetic energy if it is moving at a speed of 5 meters per second. Okay, so let's input the formula. Half, if you just put into your calculator 0.5 multiplied by 1,300 multiplied by the velocity squared. Oh, my mistake. I've just... okay, so this is for this question here. Okay, so multiplied by the velocity squared is 5 meters per second squared. We can just say 5 squared equals. Now I'd like to break this up into sections. So I'll go 0.5 multiplied by 1,300 gives me 650 multiplied by 5 squared, which is 25. And that equals, I might just use my calculator for this one, that equals 16,250 joules. 16,250 joules. Okay, so for this next one, I'd like you to pause the video and have a go at answering this question. So same car, but this time it's moving at 16 meters per second. So pause the video and have a go. Okay, assuming you've paused and had a go, let's go through it together now. So the formula is once again 0.5 multiplied by its mass, 1,300 multiplied by 16 squared. That equals, so we know half the mass is now 650, so I can just put that straight in here, 650 multiplied by 16 squared, which I believe was 256. I might just double check that just so I don't say the wrong thing. Yep, 256. And that equals, I definitely need my calculator for this, 650 times by 256 equals, so this equals 166,400 joules. Okay, so hopefully you got that answer. Pause the video again and have a go at these two. Okay, assuming you've paused the video, let's go through it together now. So this time I've got a much heavier car. So I'll go 0.5 multiplied by 2,020. Oh, this is a bit tricky. Multiplied by 2,025 kilograms multiplied by 5 squared. Okay, so that's equal to 0.5 multiplied by 2,025 kilograms. That gives me 1,012.5 multiplied by 5 squared, which is 25, equals, I'll just put that into my calculator. So that equals 25,312.5 joules. 25,312 joules. Okay, let's do the next one. 16 meters per second this time. So we've got the same mass, so you're still going to have 1,012.5 for the first part of the equation, and this time we're squaring 16, which was 256. So I should do a times sign here, and that's going to give me 1,012.5 multiplied by 256. That gives me 259,200 joules. That's 259,200 joules. So hopefully you got the same answer you did. If you didn't quite understand what I've explained here, please do come and see me. At this point, the best thing you can do is practice with the worksheets that I might have given to you, or I might give it to you next lesson, and also doing the Education Perfect modules on energy calculations. Thank you for joining me on this episode of Science, and I'll see you on the next one.